Well, all right. So now we're going to start with something called logarithmic differentiation. Don't be intimidated. This is something that you guys already know. Okay? In order to do logarithmic differentiation, you need to know three things: what not to do and what to do. So here's what you already know. You know that if I give you 2 to the x squared plus 5x plus 2, and I say y equals this, you can give me y prime, can't you? This is a nice exponential function. We know this. Okay, so what do we do for y prime? We treat this similar to e, right? So the first thing we're going to do is we're going to rewrite the entire expression. Then we're going to go times the natural log of 2. And then times the du dx, which in this case will be 2x plus 5. Done. This should be something you know. You also know how to do x squared plus 5x plus 2 squared, don't you? The derivative here would be 2 times that whole thing times du dx, the derivative inside there, 2x plus 5. Got it? So far, so good, right? And who remembers the little rule from pre-calculus? The natural log of a to the x power. What do we do with that x? Anybody remember? The x comes out in front. You guys all remember that? X ln a. So even in your pre-calculus COVID year, where you basically had camp instead of school, you did manage to get this, correct? Okay. Now, the question now becomes, what do we do when I've got a variable in the base and a variable in the exponent? Variable in the exponent, it's an exponential function. Variable in the base, that's just a polynomial function, right? What would we do when we have both? All right, so let's take x to the x squared plus 5x plus 2. Okay. Now watch carefully. There's a little algebraic trick that we use. Okay. There's no secret involved. It's just somebody figured out this is how to do this, wrote it down, and then nobody's had to figure it out since because that person did it. And basically what you do is you take the natural log of both sides. And that's the trick. And then we're going to differentiate, then we do the whole thing. And this is what logarithmic differentiation is. So look what happens. Natural log y equals x to the x squared plus 5x plus 2. I mean natural log of that, sorry. Let me just scooch this all over a little bit. Natural log y equals the natural log of that. Well, now, using your pre-calculus knowledge, what happens to the exponent on the right? It's going to come down in front, isn't it? Yeah. So now I'm not doing any calculus yet. No calculus. Not yet. We're going to in a moment. Don't worry. Right? Don't worry. It's coming, but not yet. Natural log y equals x squared plus 5x plus 2 natural log x. Isn't that great? Now, check this out. Oh, whoops, let's go over here to our memory area. Sorry. Natural log of A equals B means what? If you were to go from log form back to exponent form. If you do that, natural log of A equals B means, what is natural log asking? I'm sure you all know, what power do you raise e to get this number, right? So the natural log of 31. We're saying, what power do you raise e to get 31? Do you all vaguely some understanding of that from high school? Right? Just like the natural, or just like the log base 2 of 16 means what power do you raise 2 to get 16, right? Log base 10 of 100. What power do you raise 10 to get 100? Right? Means A equals E to the B. Or as an old Algebra 2 teacher used to say, the log is the exponent. So B in this case is the exponent. So we sure are doing a lot of pre-calculus, aren't we, for logarithmic differentiation? When's the differentiation going to come in? Hold your collective horses. It's coming. So here we go. Y equals, natural log y equals that gobbledygook means y equals e to the x squared plus 5x plus 2 natural log x. Quite done yet. Oh my gosh, we have to go back to our memory again. I keep remembering little pre-calculus rules. How about some exponent laws? How about if I give you e to the AB? That's the same thing as, no, we're okay. I think we're okay. We don't need to know that. E to the A to the B power. I think we're okay here. Okay. So now we just differentiate. So now we can differentiate this, and away we go. Y prime first, and then we have e to the x squared plus 5x plus 2 times the natural log of x. And then we take the derivative of that exponent. Product rule to me, right? First times the derivative of the second plus the second times the derivative of the first. First times the derivative of the second plus the second times the derivative of the first, and that's your answer. Now, sometimes you can simplify it, but that's basically our answer. Okay, and this is logarithmic differentiation. So you've taken the natural log of both sides. And this is how it works. Natural log both sides, put it in exponent form, do your derivative. What's the point? Why? It's because of that little log property where the exponent comes out in front. In other words, you get rid of the exponent. Of course, you recreate it in exponent form, but it's only one exponent and the base is a constant. Oh, we know how to take this derivative. I don't know how to take this derivative. This is a good lesson for not only calculus, but also life. take something you don't know how to do and turn it into something you know how to do. That is your life lesson of the day.